Good afternoon, calculus type people. How is everybody doing today? Hope you're all having an amazing day. Today we're going to be talking about limits of trigonometric functions, trigonometry. All right, so there's some special trig limits we need to address real quick. First off, the limit is x goes to 0 of sine x over x. The limit is x goes to 0 of x over sine x. Limit of x goes to 0 of 1 minus cosine x over x. These are all special trig limits. Usually you wouldn't be able just to plug this straight in because you would get undefined answers for all of these. But in this case, what we do is we're identifying them as special limits. So the limit as x goes to 0 of sine x over x is 1. Limit of as x goes to 0 of x over sine x is positive 1 again. The limit as x approaches 0, 1 minus cosine x over x is 0. These are their limits. It's the way they work pretty much. So it's pretty cut and dry. These are your special limits. All you have to do is remember the rules, and you can go from there and be fine. So, example 1 here, it says find the following limits. You know from experience that the very first thing that you do for limits is plug them in. Always plug them in. So as x approaches pi, this is going to be basically the tangent of pi, right? And we all know the tangent of pi. If you bust out that unit circle, you need to have that handy if you want to pause and get that real quick. The tangent of pi is 0. So the limit as x goes to pi of tangent x is 0. Okay, keep going. The limit as x approaches 5 pi over 3 of cosine x. Well, that's cosine of 5 pi over 3. 5 pi over 3, if you remember, it has a reference angle of pi over 3. This is in quadrant 4 here, so your cosine is going to be positive, so it's 1/2. 1/2. All right. Then you have the limit as x approaches 0 of tangent x over x. Now we can't plug this one in because we end up with tangent of 0 over 0, right? So at this point, when direct substitution yields an indeterminate, meaning something over 0, we use special limits. So here's what this one is going to look like. I'm going to rewrite tangent as sine over cosine. Limit as x goes to 0, sine x over cosine x over x. Now, if I wanted to, I can rewrite that as sine x times x, actually. Or excuse me, sine x over x, times 1 over cosine x. If you were to set this up, it's basically the same thing as saying sine over cosine. Let me zoom in a little bit for you. It's basically the same as saying sine over cosine times 1 over x. So you can flip those denominators, and it's perfectly fine. That is mathematically, that's okay. Right? So it's saying, let me write it over here for y'all if you don't see it. Sine x over cosine x times 1 over x. If I flip these, I still end up with the same thing because multiplication with fractions just goes straight across. So I could do sine x over x and 1 over cosine x. That's perfectly fine, perfectly legal. Now you know from up there that the limit as x approaches 0 of sine x over x, all of this goes to 1. So that's 1 times this. So here we are, the limit as x approaches 0. 1 times all this is just going to be 1 over cosine of x. Now plug in your 0. 1 over cosine of 0. And the cosine of 0 radians, cosine of 0 here, this is 1. So it's 1 over 1, which is 1. Remember, you're writing this as your limit. As long as you write it with the limit in the beginning of the question, it's okay. All right? So that all simplifies to 1. All right, next, you have, let me get this out of the way there, sine of 4x over x, and again x is going to 0. So I'm going to get a little clever with this one. It's very close to being sine x over x. The only thing that's missing, let me write this down, the limit as x goes to 0. The only thing that is missing is this x having a 4 down here, right? Well, if I wanted to add a 4 down here, let's say I want to add a 4 down there so that this can go to 1, like it says up in the top. If I want to add a 4 down here, I can't just add it down in the bottom. Anything you do to the bottom, you have to do to the top, right? So watch what happens here. What we're left with is 4 times, and all of this, sine 4x over 4x, can go to 1. So what I'm basically left with is 4 times 1. And there's nothing to plug in for x, so it's just 4. This is a little clever here. You do have to be a little clever with this one. 4 times sine of 4x over 4x. You do have to be a little clever, but it's completely doable though. It's completely doable. All right. Where am I at? Let's go to 5. All right, now number 5. Number 5 is an interesting one. I'm a fan of number 5 for a couple of reasons. Starting off on the top, you've got a cosine squared x minus 1. What you have to recognize right off the bat is that you are actually dealing with the difference of 2 squares. You are actually dealing with the difference of 2 squares here. Okay? So there's a couple of things I'm going to do. First off, for starters, let's go ahead and factor that out. Limit as x approaches 0. Cosine squared x minus 1, if this is cosine squared, you're talking about cosine and cosine multiplied together. So it's going to be something like this. Cosine of x plus 1, cosine of x minus 1, all over x. Right? Okay. Now this cosine x minus 1 over x, that's really close to this. The only difference is the sign. It's 1 minus cosine here, and here it's cosine minus 1. It's very close to giving me 0. So what would I miss in that case? What's missing out of that? All right, so the first thing that I would do is look at how could I make this become a positive 1 and a negative cosine. Well, one way is to pull a negative out of there, right? And if you pull a negative out of here, like this, it's going to make this a negative cosine and a positive 1. And that will go to 0. So it's kind of like these will divide out here, right? So let's see what that'll leave us with. We'll have the limit as x approaches 0 of negative cosine x plus 1 times 0. Well, that seems simple enough. Negative cosine x plus 1 times 0, that's all 0. So your limit here of cosine squared x minus 1 over x as x approaches 0, I'm on a new line so I have to rewrite my limit, is 0. Alright? So it's a fairly straightforward lesson today. There's going to be a couple of these where you'll have to go through and do a few things as far as simplifying and as far as using these special trig identities, these special trig limits here, and simplifying some of these other ones. But remember, your first step should always be to plug in. You should always, very first thing would be to plug in. All right. After you plug in, if you get an indeterminate, something over 0, then you can worry about going through and using your special trig limits or factoring it or using a conjugate. All right. So a shorter video today, only about 10 minutes. I hope everyone is doing amazingly. Please come in for tutoring. If not, I will be here. There's no one here right now, so come in. All right.